We've been finding areas under the curves between the curve and the x-axis, but we kind of already cheated a little bit because we've done some AP questions that the area was not between the curve and the x-axis, and we used geometry. So some of this will probably look familiar to you, but here's what I'm trying to say. So make a notes here on the right-hand side. So if I have a x-axis and a y-axis, like so, and I have an f of x, and I have a g of x. So I'm going to call this blue curve f of x. I'm going to call this green curve g of x. And I want to find the area between A and I'm going to say this is B, but I don't want any area. I want this area. Then I hope that you guys could probably figure out that it's the area under the curve of f of x minus the area under the curve of g of x. And you might do something like this. You might say something like area under the curve from A to B of f of x dx minus area under the curve from A to B of g of x dx. Are we still okay or no? But if you remember from properties, maybe last week or 2 weeks ago, because I can't remember when we did properties of integrals, you said, hey, wait a minute, that's A to B, that's A to B. So can I combine this to just do one general integral? Yes, and you can say one general integral from A to B, and you can put it in parentheses, f of x minus g of x, close, close, dx. And there it is. No. It actually it's preferred, but don't ever freak out because that dx must be there. Don't freak out. That does not mean that it's the d of x with g of x. That is f of x minus g of x, the whole shebang, and then d of x in d of x. Or d of x means delta x first of all, but d of x means the end of that integrand. Does that make sense? So make sure that you insert your dx in there, and then of course all that you just got to do antiderivative now. Cool or not cool? All right, so that's what we're doing. So check it out. So this curve here in black, that is the square root of x. And then this linear line here in red, that is x minus 2. Notice that they cut this up into two regions. There's a reason for that. Square root of x, the region A, just goes between square root of x and this 2 here. So region A, so I'm going to say region A. You can get region A by just doing integral from 0 to 2 of just what? Square root of x. I hope we know enough to do that by hand. Say it again. Because this is the only curve that is between the x-axis and that curve is square root of A. So square root of A minus... You can also think of this, if you want, you can think of this line as y equals 0. So it's like square root of x minus 0. But I would just leave it like that. All right, let's see. Can we do this by hand? 0 to 2, x to the 1/2 dx. All right, let's see. What's antiderivative of x to the half? X to the 3/2. Yeah. 2/3. So yeah, so let me tell you guys how to do it real fast. Ready? Add 1 to this, and everyone can do that fast. X to the 3/2, and yes, you can divide by 3/2, but whenever it's a fraction, that's the same thing as multiplying by the reciprocal. Does that make sense? And then I put one little line. You can put a bracket if you want. 0 to 2. You always say the bottom one first, 0 to 2, because you're showing direction of the integrand. And then when you evaluate it, you're doing upper minus lower. So because both terms are going to have 2/3, I'm going to factor it out. So look, I'm going to help you guys to do more advanced stuff. 2/3, and I'm going to write 2 to the 3/2 minus 0 to the 3/2. And I guess maybe you could say, Chav, but the 0 to anything is 0. And you're right, so maybe I didn't have to factor out that 2/3. Are we cool? All right, how do we evaluate this? Relax, it's easy to evaluate it. 2 to the 3rd power is 8, and the square root of 8 is? Yeah, so 2/3 parenthesis 2 square root of 2. So my final answer is just 4/3 square root of 2. Or you can say 4 square root of 2 over 3. That's just for region A. Are we okay? Now I'm going to do region B in a different color. So let me go ahead and color code this so you guys can see. There it is. Everything in red is with everything in red. Now I'm going to do everything in blue here. It should be color coded. I'm going to do it with everything in my blue color. I just got a fresh marker. It has fresh blue ink. Guys, it's a digitizer. I don't run out of ink. All right. Oh, that was fun. Oh, man, this. Okay. Upper minus lower. Here's a hint to really help you out because it's going to definitely help you out when you're integrating with respect to y. Draw a vertical line, just a random one, so you can see your slices. What line is on top? The square root of x. What line is the bottom? X minus 2. Do you guys see that? Yeah, so I just draw a random vertical line just to see my slice. Those are all dx's because they're all horizontal. Okay, anyways. So here we go. I'm in blue. Everything in blue is that region in B. So I think I have enough space down here, so I'm going to put region B. Am I right? Equals integral from 2 all the way to 4. 2 to 4. Oh, I wrote 2, but it didn't write it. And then the curve on the top is square root of x minus the curve on the bottom is the linear line, which is x minus 2. So I'm going to do it like this. Why what?
Wait, would it not be, oh, is it because, okay, so like the total area from square root of x all the way to the bottom?
Which is, no, I don't want all the way to the bottom. I just want it to the,
and then you subtract
this is f,
area under like x minus 2.
all I'm doing is this, f of x minus g of x. The square root of curve is like f of x. The linear line is like g of x. So I did square root of x minus 2. But I'm not going to evaluate, like, look, I know the answer is here, but don't look at that.
Okay,
Yeah, so here it is. Don't evaluate it yet. Distribute the negative. Put negativity on everything. That was a joke, but it wasn't funny. It flew over your guys' heads. Distribute that negative. Distribute that negative. Square root of x minus x plus 2 dx. Now it should look the same as what the integrand is on the very top. Is everyone okay? Do we have any questions? All right, here we go. I already know what the antiderivative of the square root of x is. We did it earlier. That is what? Yeah. 2/3 x to the 3/2. Because I have more than two terms, because I have more than one term, put everything in a bracket. 2/3 x to the 3/2 minus what's the antiderivative of x?
1/2 x squared.
Perfect. I like to write x squared over 2, but that 1/2 x squared is the same. What's antiderivative of 2? Plus 2x. There's my three terms. Close the bracket. What do I put in the bottom of that bracket?
2.
A 2, and in the top? 4. So when you're explaining this to a professor, you tell them antiderivative is this from 2 to 4. So now we're going to evaluate. We're going to do upper minus lower. There's nothing to factor because you got more than one term, unless you see something that is in common for all of them. There isn't. So you guys ready? So here we go. I'm going to do a giant parenthesis. I'm going to plug in a 4. 2/3 parenthesis 4 to the 3/2 minus 4 squared over 2 plus 2 times 4. Close, close. That's my 4 minus, open another parenthesis. Now I'm going to use the 2. I don't know if I can fit it all, but I will try. 2/3 parenthesis 2 to the 3/2 minus 2 squared over 2 plus 2 times 2. Close, close. And I got a little bit of space right here in the on my top margin. I'm going to go ahead and use that. All right, let's see. First parenthesis, the square root of 4 is, I'm doing this part right here first. The square root of 4 is 2, and 2 to the 3rd is 8, and 8 times 2 is 16, and 16 divided by 3, does that reduce? No, so 16 over 3. And then 4 squared is 16, and 16 divided by 2 is 8, plus 2 times 4 is 8. So that's my first big parenthesis minus, let's see, 2. This time I'm going to do this first, the 2 to the 3rd. 2 to the 3rd is 8, and then the square root of 8 is 2 squared root of 2, and then times 2/3, so that's going to be 4 square root of 2 over 3. And then I think that says minus, right? 2 squared is 4. 4 divided by 2 is 2. And then finally 2 times 2 is 4. All right, so let's see what that is. These 8's cancel out. So I have 16 over 3 minus, let's see, 4 square root of 2 over 3 plus 2, right? All right, so now what am I going to do? Well, I haven't distributed yet on mine. I'm going to turn that 2 into, I see 3's everywhere as the denominator. So I'm going to turn that 2 into 6 over 3. Is that okay with you guys? And I think I still had a plus there. Okay, now we're good. So here we go. One thing. What is, I'm going to distribute this negative. So that's going to turn to a negative. That's going to turn to a negative. So I'm going to have 16 over 3 minus 4 square root of 2 over 3 minus 6 over 3. So that is 16 minus 6 is 10 minus 4 square root of 2 over 3. Okay, well, finally, we're not there yet. What's up, miss? Where'd the what come from? This guy? I did this negative 2 plus 4, which was 2. All right. Finally, here's my answer. Region A plus region 3. Do I got space up here? Okay. So what was my answer for region A? I'll write it in red. Okay, 4. So I'm going to write here, region A. Way up here, guys. And then neutral color green. And then region B, I put it in what color? Blue. Plus region B. I don't know why it came out looking ugly like that. Equals. And you guys just told me it was 4 square root of 2 over 3. All right. 4. There's a lot of lag. Sorry, guys. Square root of 2 over 3. And there's so much lag, the equal sign didn't even come out. There we go. Plus. And then give me what I had for the blue. 10 minus 4 square root of 2. All this is over 3. All right, perfect. Here's my answer. Everything's over 3. What's going to cancel out? 4 square root of 2's cancel out. And I just have what? 10 over 3 is my answer to all that work. And that's it. That's the area. That's the area between f of x and g of x, or that's the area of a and b. And I did these notes on purpose. We're going to be finding that area many different times with different methods, and you guys will decide what method you want to use. Cool or not cool? And look how beautiful all this math works looks, guys. Okay, if you turn the page, is it that same area? Where do you know what that region is? What's that answer supposed to be? 10 over 3. Check this out. Look how beautiful this is going to be. So this says find the area of the region. We already know what it is. By subtracting the area of the triangular region from the area under the square root curve. Do you see that triangle? I'll write it here for you. I'll put it here in black. Look at this triangle right there. So what they're telling me to do is to just find the area under the square root curve, which I'm going to do in red. Here it is in red. And they're telling me find all this in red, and then just subtract what's in black. Okay, I'll do that. Again, there's the perfect one for colored pencils, guys. I'm going to do the red in red, and then the black in black in a little bit when I get there. Integral from what to what? 0 to 4 of the square root of x dx. I already know what the antiderivative of a square root of x is. We did it in the last page. Do you guys remember what the antiderivative was? And I'm going to put a line, and I'm going to put 0, 4. You can also put a bracket, but it's common, a line. And why is a line common? Because if you're in computer science, if you're programming, that line means evaluate in computer science. I don't know if you guys are programmers. Okay, ready? All I'm going to do is plug in what number? The 4, because the 0 we already know is 0. So let's see. 2/3, parenthesis, 4 to the 3/2. So that is, the square root of 4 is 2. 2 to the 3rd power is 8. 8 times 2 is 16. So I just get 16 over 3. Does everyone get that? All right, now let's do the area of the triangle. So now if you have colored pencils, here it is. I'm going to put triangle in black. That's what the area is. I'm trying to take good notes because that was one of y'all's things. Like, you want more detailed notes, so I'm trying to color code stuff. All right, here we go. Does everyone know how to get area of a triangle? 1/2 base times height. What is that base? From 2 to 4, what's that distance? 2. What is the height? 2. 2 times 2 is 4, and half of 4 is 2. So here we go. I'm going to pick a neutral color like green. So I'm going to say area of region A plus B is, let's see, and then I'm going to write my colors, 16/3 minus the what? That's the same, region minus 2, which 2 we said is the same thing as 6/3, and look at that. 16 minus 6 is 10, so 10/3. Did I get the same answer as before? Was that a lot less work? Yes. Cool, right? All right. Did I? All right. Don't freak out. Relax. So these pictures here are telling you that you can also integrate with respect to y instead of x. These are still Riemann sums. Look at those rectangles. Instead of those rectangles being vertical, now they're horizontal. Do you guys see that? So these right here are no longer delta x's. Look at that gap right there. That gap is a delta y. Do you guys see that? So when I tell you when I tell you to draw a horizontal line, I'm gonna say that's a slice, but that's not a dx. That's a dy. Does that make sense? It's with respect to the y now. See this rectangle? Like we have another rectangle here, and this time these are your delta y's, and your height is the horizontal. Cool or not cool? Okay, so what this means, guys, look, notice that it says x equals f of y. So this means integral, and notice this has the letter C and the letter D. We'll talk about that in a little bit. Well, I guess we should talk about it now. So C down here, D up there, and then upper minus lower. What's upper? When you draw your vertical line or your horizontal line, sorry, it's the upper one is the one in the rightmost, right minus left. So f of y minus g of y. It's the same concept. How do we feel? And it doesn't matter if we're above the x-axis or below. This is what they're trying to show here. See here, the bottom limit is still C, the top limit is still D. Cool or not cool? All right, so let's see. Now they say find the area of the region example 1 by integrating respect to y. Okay, so here we go. We had two curves. So I'm gonna go ahead and color code them here. Come on, buddy. Okay. We had f of x equals square root of x. Should I draw it? Yeah, I'll draw it. It's going to be a bad sketch, though. It's not going to be a good sketch. Square root of x, and then line. This one was f of x equals square root of x. And then this one was g of x equals, was it x minus 2? Or no? It was? Okay. And if it's not, I'm going to have a different answer. And then I still want this area. Ready? I want to, this time my slices, here are my slices. It's in blue. This curve is top, this curve is bottom. Remember, I have a rectangle right here. So that's a dy, not a dx. So if it's a dy, that means my expressions need to be in terms of y's. And I need to use these values up here. So don't worry, we'll talk about that. Here we go. Red. Y equals square root of x. I want it in terms of x equals something. So I need to square this side, square this side. X equals y squared. Am I okay? Okay, underline that one. Now I'm going to do the other one. What color do you want me to use? Blue? Okay. Y equals, we said that was x minus 2. All you got to do is move the 2 to the other side. So here we go. I'm going to write it in terms of x. X equals y plus 2. Are we okay? Oh, because I'm going to integrate with respect to y, not x. Oh, I'm going to take an antiderivative. But but I'm not doing it in respect to x. I'm going to do it in respect to y. Yeah, if I were to type this in Desmos, it will give me the same line. If I were to type this in Desmos, don't worry, I see this. It would give me the same curve, but it would actually also give me this down here in the bottom as well. Are we okay so far? Okay, what's up, little Torres? Yeah, so maybe I should have changed it to green. It's this line here. There we go. I changed it, miss. Sorry, guys. Okay, are we still okay? All right, so here we go. I'm going to write integrand. Which one's first? Remember, when you draw the horizontal line, it's the rightmost. What line comes first? The y plus 2. So I'm going to put it first in parentheses just in case I need to distribute something. There isn't, but minus, and then the square root curve comes next, which is what? Y squared. Nothing happens with those parentheses, so you can just drop them. And then I'm going to put dy right here. You got to have that dy. If you want to put parentheses like that in the sides, that is fine. What's up, Lopez? Yes, I do. I was waiting for the very end. Now, my new limits, do not use the old ones because those were x values. Now I need what? Y values. What is this? Let me put it in red. What is this y value right there? 0. Do you guys see that? What is this y value way up here? I'm going to put a dashed line. What is that y value right there? 2. Does everyone know how we got that y value of 2? It's where they intersect. Good. I needed someone to ask. So it's where they intersect. Square root of x equals x minus 2. If you didn't know where they intersect, this is what you would do. And you would equal them to each other. Or I guess you could do the other ones. You could do this. Sorry, guys. You see how this says x equals and that says x equals? Y squared equals y plus 2. Oh, child, I don't know how to figure that out. Yeah, you do. Look, move everything to the left. Y squared minus y minus 2 equals 0. This will actually give you both limits. And then look, how do you factor that? Like this. Y minus 2, parenthesis close, y plus 1 close equals 0. And OMG, look at this. Y equals negative 1, y equals 2. By the way, the negative 1 does have something, but okay, we'll talk to you about that. Y equals 2 is the one you want. What is that negative 1? That negative 1 is actually this. If this curve continued like that, and that green curve continued like that, that intersection way here is at negative 1. Does that make sense? You don't need it. Yeah, you don't need it. But if we needed it, does that make sense? Yeah. I know, but just in case, because they're not always going to tell us. All right. Sorry, guys. Yeah, they did tell us the intersection, so you don't need to do all that. But if they don't tell us the intersection, that's how you would do it. UH doesn't tell you the intersection. They just say, find the region. When you draw your horizontal line, the rightmost curve is considered top. See this horizontal line in blue? The rightmost curve, which is the green one, is considered top. Yeah, when you draw a horizontal slice, here's a horizontal slice. The rightmost, so if you were to rotate this 90 degrees, the green line would be on top. If we were to go, yeah.
Besides determining which one's the most rightmost, what does the line do?
It helps you with your slices. That's a dy. You know, see here that you have a rectangle here, so it helps you. It helps me. Okay. Maybe you're at another level and you don't need to, but it helps me when I'm doing it. Like, oh, that's a dy. Okay. Cool or not cool, guys? All right, here we go. Usually you want to put this in order from highest degree to lowest, but you don't have to. I'm just gonna go right into it. Is that okay with you guys? Say no. Ask. I'm just finding area. Take an antiderivative. Here we go. Antiderivative of y. What's antiderivative of y with respect to y?
1/2 y squared.
Yeah, y squared over 2, or 1/2 y squared, same thing. Plus, what's antiderivative of 2? 2y. Minus, what's antiderivative of y squared? Yes. I have more than one term, so I put it in brackets. I put a 0, I put a 2. I don't care about the 0. Yeah, ask. I don't care about the 0 because I see that every term with a 0 in it is going to be 0 anyways, so just plug in a 2. 2 squared divided by 2. 2. 2 times 2. 2 to the third power. So 8 over 3. Let's see, is that the same thing? 4 plus 2?
Oh, 6.
So 6 minus 8 thirds. Turn that 6 into denominator 3. So 6 times 3 is? So look at that, guys. 18 over 3 minus 8 over 3 equals 10 over 3.
Yeah, how did we?
Because it's the same. Is it not the same region? So you're supposed to be getting the same answer no matter what. Yay or nay?
Charles, when if let's say this is the FRQ question,
And they probably will be.
should I just circle 10 over 3 or?
I wouldn't circle anything. I would just be like, yeah.
Or would I have to?
I circled it, but
Would I have to put like the integral from like 0 to 2 y plus 2
yes.
y
If
squared dy equals 10 over 3?
if it's a calculator section, you just show the setup and then equals the answer. So yes, if it's a non-calculator, they're gonna want to see you do the antiderivative.
So when I finally get my answer.
If within the sentence it just says find the area, then it's understood. But I think that's still the direction that they want. Like the area of this region is blah blah blah.
Okay.
Okay.
Oh, I can do that.
All right, you guys need your calculators for this one.
I calculated I think it's 10. Or maybe like on the verge.
Everyone, take out your calculator for this one. This is 100% calculator. So we can learn how to use. We're going to put the equations in. All right, so here we go. Find the area of the region enclosed by the graph. So notice that they want a region, and it's enclosed by these graphs. Y equals x cubed, and x, notice that they told us an x. X equals y squared minus 2. So first we're going to do it with respect to x, and then we're going to do it with respect to y, and you're going to see which one's easier. Obviously, I think with a y is easier, but we'll get there when we get there. Okay, it intersects in 2 locations, and they're not giving me the intersections. By the way, you can tell what graph is what, right? The graph in the top here, that's y equals x cubed. And then real quick, this top half, I guess, should I color code it? Okay, yeah, we'll color code it. I'm going to put this one in blue. And so let's see. So first I'm going to write the general expression. X equals y squared minus 2. Remember, I'm going to do it with respect to x first, so I need it in terms of y equals something. Move that 2 to the other side. Y squared equals x plus 2. And then square root, y equals plus minus square root x plus 2. So the one in blue is y equals the positive square root of x plus 2. And the one in green is the negative square root of x plus 2. The one in blue has y values that are positive. Abdul Kareem. The one in blue has y values that are positive. So because they're positive, it's and you can't have like the square root would never give you a negative output, right? But with the negative in front of the square root, all these y values are negative. The ones in green. You know what I mean? All right. In y1, type in x cubed. In y2, type in square root of x plus 2. In y3, type in negative square root of x plus 2. So, yes. To be able to plot it into the calculator, because the calculator does not have an x equals part. It has y equals. You know what I mean? So here we go. Y equals x cubed. Oops, I have a junk in there. Hold on. X cubed. And then square root. Was it x plus 2? And then the other one was negative square root x plus 2. All right. Hook me up with the window they gave me. In the bottom, it says x is between what and what? Negative 3 and 3. By negative 3 and 3. Now it's a lot easier with a colored calculator, guys, because you can see all these different. Oh, I should have chosen the colors that I chose. Oh well. And look how beautiful that calculator, how that image looks. All right. Yeah. All right. What do you think? Oh, you probably put a minus instead of a negative. All right. Are we okay so far? Can everyone do that? All right. All right. Here's what I need. It looks like, okay. It looks like, do you still get air? Check your window. There. You have to turn off a plot before you can graph. Because then you just have random data trying to prod and it won't work. Okay. Is everyone okay with that? Make sure you get really good at being able to do that. All right, next. I can see, it looks like to me that this x value here is 1, or negative 1, sorry. It looks like to me, but you can never be too sure. Well, actually it is, because I just realized the equations. But if you didn't know that, here's what you would do. Second, calculate, and then intersect number 5. And then what curve? The blue one, enter. And I notice it goes to the red one. I don't want the red one, so I push down. I want that black one, enter. And then it says guess, nope. And sure enough, it is -1, -1. So remember that that's -1, -1. Are we okay? But this one up here is definitely not a perfect coordinate. So here we go. And we're going to need both the x and the y. So here we go. Second, calculate. Number 5, intersect, enter. Red curve, yes, enter. Let's see, where am I? What curve are you? Oh, yes, I only have one intersection. Enter. Did I find it? Yep. I want to say both, because we're in a little bit. We're gonna integrate with respect to y in a little bit. So here we go. Does everyone have these values? All right, do you have those values? Okay, do second calculate, number 5, and then enter, make sure that it's the blue and the red. Yes.
Well, if you get like a crazy one, like 1.2.
Yeah, you got that right. Yeah, it's not perfect. Okay. Here we go, guys. We need both of these values. We're in 2023. We need to know how to make sure that we know how to use technology. I want both of those values stored in my calculator. Okay. So go to your home screen. I'm gonna push X, and I'm gonna push. Well, first let's push Enter to make sure it's our value. There it is. Is that our X intercept? Push Store. It was. If it's not, that means you didn't do it right. Alpha A.
No, I got inverse at 5, 4 equals 0.6.
Why did you push inverse 10?
I did it.
Oh, then all you have to do is push X.
Oh.
Okay. I also need the Y. I also need the Y, guys. How do I get the Y? Do you see it in green? Push alpha, Y, and push enter. Was that, I don't know, hopefully you didn't forget, but does that look like the Y-intercept that you had earlier? store that. I go down the alphabet, so I'm going to store that into what? B. I'm going to need it. Are we okay? Did everyone do that? Okay, here we go. Here's our game plan. I'm going to integrate, so here we go. I'm going to draw a line. Do you guys see that? So I can see upper minus lower. I see that blue curve and I see that green curve. So I'm going to integrate from, let's see, -1, -2. From -2 all the way to -1. That's a negative. It just, there we go. And it's the blue curve, which is positive. So square root of x plus 2 minus the green curve, which is negative square root of x plus 2. Are we okay? Okay. Now, guys, I know you guys are smart. You could have also said this. You could have also said, Chavez, the area from 0 to 2 of under that square root curve, whatever that is, if I just double that because it's symmetric, it's the same. Yeah, you're right. You could have put a 2 in the front and just done one of the integrals, just one of the square roots. Does that make sense to you guys? Should be the same. All right, but that's just to get that part. Now, look at this. I have a different region for this part. From -1 all the way to letter C, which is whatever we saved the name. Do you guys see that? So I'm going to write dx plus, and then I'm going to write integral from -1, where the other one stopped, and then all the way to A. And I'm going to put in here that the x, that this, oh, I see, yeah. But I you know what? I'm going to put capital A because that's what I saved it at. Yes. And capital B.
Can you shade in like the area?
Yes. Yes, we're finding this area. We're finding this area, all that.
Can you do the
In different colors? Yes.
What if you put the integral in the same color that you did it? Does that make sense?
But it's not the same color.
No, but like what if you put the integral in the color you did it?
What do you mean?
The integral symbol.
Oh, got you. Yeah. The blue part, yeah.
Like that.
Yeah. So here's the blue part, just like we did the other notes. I'm trying to write good notes for you guys. The green line was the negative square root one. So there's the blue region, and here's the red region. -1 to A, the capital A, that's stored in my calculator. What's that top curve? Square root of x plus 2. And then the bottom curve is? X cubed. Lunch. All right. We're back where we finally left off. How do we, so let's find this intersection again. There it is. 1.21, 1.79. I'm going to go to the home screen. And yeah, I don't know what you guys did to her, but you guys, all right, here we go. X, enter, store that to A, alpha A. Here's another run at it. And then I'm going to go alpha Y equals, or alpha Y, enter. There it is. That's my B. So I'm going to put store alpha B. Okay, we're back. So here it is. From -1 to A, from -1 to A of the square root of x plus 2, that's one to the top, minus, what's on bottom? X cubed dx. This is going to give me my area, right? Okay, now look, guys, you guys can be smart because you guys already have this in your calculator. This is in your y2, remember? That's what we said. This is in your y3. This is your y2, and that is your y1. So that's how your calculator is going to look. Here we go. Math 9 from -1, from -2 to -1, right? And then in here was alpha trace y2 minus alpha trace y3. There we go. Get out of there. X plus math 9 from -1 all the way to alpha A, right? And then what curve do you have on top? Y2 minus Y1. And then everything looks good. Let's see, push X, enter. Everyone should get this answer, digit per digit all the way. 4.21494. Did you get that answer?
Yes.
All right, write that down. That's your answer. That was a lot of work. 4.2149. 4.2149.
Actually, wait. I have a question.
Yes.
Oh, never mind. Wait.
Ask.
The integral. Oh, never mind.
All right. You guys saw how much work that was, right? Okay. If you would have done it, all right, guys, focus, focus. If you would have done it with respect to y, you only have to do one integral. You don't have two. And all that work. Look, draw a vertical line. Draw a vertical line, and notice it's always this line here, x cubed, minus the other one. Do you guys see that? Are we good? Do you see that or no? It's always, okay, guys, focus, focus. If I draw a vertical line, no matter where I draw a vertical line at, notice it's always the x cubed line minus the quadratic in the x-axis. Do we notice that? It's always, look, right minus left. It's always the black line minus either the blue, or if I continue to make this blue, it's always black minus blue all the time, no matter what. Cool or not cool? Because the black line's always on the rightmost, no matter where I draw this green line. Okay, so here we go. I'm going to integrate. I'm just going to do it one time, guys. Integrate. The rightmost curve is x cubed. So I need this in terms of x. Y equals x cubed. I need this in terms of x equals something because I'm going to integrate with respect to y. Those are dy's. So that means that x equals the cube root of y. Does that make sense? So that's what I'm going to type in here. The cube root of y minus this curve in blue was already given to us right here, guys. That's y squared minus 2. Minus, parenthesis, y squared minus 2. Close, and then put a dy. Now I need my new limits. I'm integrating in respect to what variable? Y. So what is the y value down here? Negative 1. The y value up here, I use what letter? B. So I'm going to put B. And that is the y-intercept, or the y value of the intercept. Y value of intercept, where the two curves intersect. Are we still okay? Now, that's it, guys. I'm done. I'm just going to type that in. Here we go. In my calculator, how am I going to do it? I'm push math 9. I'm going to put negative 1 in my lower curve. In the top curve, I'm going to put alpha b. Yes, you can type cube root of y. I'm just going to type cube root of x. It's the same. It doesn't matter. Remember, it's a dummy. It's a dummy variable. Number 4. You can also use number 5, and then put an x in there. Minus, and I don't think I distributed it, so I'm going to put a parenthesis. Minus x squared minus 2. Close it. Make sure that you use y on the paper, though. With respect to x, it better be the same value. You ready? Enter. Look at that. Was that the same thing? Yeah, it was 4.21. Oh, well, yeah. There's some differences after the 9. But after the first 3 digits after the decimal, are they the same?
Yeah.
Yeah, they're actually the same all the way to the 4th digit after the decimal. That's why they say the 3rd. There's going to be some discrepancies because the calculator has tolerances. 4.214 or 4.215. 4.2149. That's why they stopped being the same. So 4.2149. There it is. Which one was easier? The one with x's or one with y's? Bless you. The one with Y's, guys. Cool or not cool? All right. Here we go. Last one. I think this is the last one. Oh, we got two more. Sorry, guys. We got two more. But they're basic. Find the shaded region is shown below is bounded by the functions blah and blah. You can tell which one's which. This one's the f. And the linear line is the g of x. And the y-axis. And the line x equals 1.5. Okay, this is line x equals 1.5. All right. Find the area of the shaded region using the calculator rounded to the nearest thousandths. Okay, ready? What curve is on top? I'm just going to draw. You have to integrate this with respect to x. What curve is on top? The parabola, f of x. Integral between 0 and where they intersect. I'm going to have to find where they intersect. Oh, it's at 1. They're being nice to me. And it's f of x, so I'm going to write negative 4x squared plus 9 minus g of x. Negative 2x plus 7. I'm not going to put the dx. I'm not going to type it in like that. I'm going to type in 4x squared plus 9 and y1, negative 2x plus 7 and y2. So here we go. Y equals. What? I was trying. Okay, I'll slow down this. Negative 4x squared plus 9 in y1. And then y2, I'm going to put in negative 2x plus 7. All right, here we go. Math. Oh, actually, I still got to find. No, I already found my intersection. Do I need two integrals? Yes, I do. That's just the first region. I should have continued. That's just the first region, guys. Plus integral from 1 to 1.5, and then now the linear lines on top and the quadratics on bottom. So negative 2x plus 7 minus negative 4x squared plus 9 dx. Now remember, I put this in y1 and I put this in y2. So y2, y1. Okay, here we go, finally. Math 9, 0 to 1. And I think I do have them in there, yeah. So it's going to be y1 minus y2. So go alpha trace y1 minus alpha trace y2. Put an x. And then plus math 9 from 1 to 1.5. And this time it's y2 that's on top. Alpha trace y2 minus alpha trace y1. Enter. Did you get 2.58333? There it is, guys. 2.5833. It says rounded to the nearest thousand, so you would just put 2.583. Cool? All right. Look at this one. This one you can do it with the x or with the y. It doesn't matter. I think with the y, but with the x is also easy. Just as long as you remember that this line up here is like y equals 0. So then that's going to be a negative. What's up? We'll do it with y also. Because I see that if I draw a horizontal line. Oh, we can't do it with y. I mean, you can, but it would be just as long. If I do a vertical line there, I have the linear minus quadratic. If I do a vertical line, did I say vertical? Horizontal. If I do a horizontal line there, it's parabola minus linear. So it would be 2 integrals long as well. All right, you guys ready? I'm going to integrate from 0 to 4. 0 minus square root of x minus 2. I'm doing that to force a negative. If you do not do that, you will not get a negative answer. I put a 0 in the front minus that. If you were to just go square root of x minus 2 from 0 to 4, oh, you might get a negative because there might be more under the curve. But yeah, it's like this. Watch. I'll show you why.
I mean, it tells you y equals 0. So it corresponds to y.
Well, that's also my x-axis, right?
Yeah.
So look, square root of x minus 2. Look, I'll show you the difference, guys. I'm going to go to y equals. I'm going to clear y1. And I'm just going to put square root of x. What was it? Square root of x minus 2? Okay. Yeah, so it's only the square root of x that's in the square root, right? Or no? Let me look again. Yeah, square root of x. Okay, so look what happens. If I go math 9 from 0 to 4, 0 to 4, and then if I just put alpha trace y1, and I put x, I get that answer. Oh, I guess that's fine. But the reason why, yeah, look, this is negative because it's below the x-axis, right? But am I supposed to get a negative answer? No, well, it's below the x-axis, but right now I'm just finding area. And is area ever negative? No. So I'm supposed to get a positive answer. So if you put that 0 in there, instead of a negative, you'd get a what? A positive. So look at the difference now that it makes. I'm just going to scroll up. I'm going to put 0 minus y1, which is the same thing as saying negative, right? Second, insert 0 minus. So 0 minus y1. Now look, it's going to be the same thing, but positive. Cool or not cool? Because area, if you're finding area of anything, it's always going to be a positive value. Yay or nay, guys? Did I confuse anyone there?
Well, I was just thinking, Travis, it's coming from to do 0 because it tells you that the horizontal line y is 0, like as part of the value. Oh, so then that means
Yeah, you're fine.
like top minus bottom.
Top minus bottom. Y equals 0 minus, yeah.
Okay,
Yeah.
that's what I.
How do we feel, guys? That's it. And I think at the moment, I just put known calculator delta math. So you do the first one without calculator, and then that we're going to call it a day after that. Just for the first 7 questions. It won't take you long. They're all simple ones, just so you can get used to it. Ask Silvera. Oh, yeah, because when I typed it, I wanted to do both. Yeah, let's do both. You guys don't have to follow along anymore, guys. We're done. But look, in terms of y, we would have done that curve, right? That minus this curve right there. So we would have gone y equals square root of x minus 2. Move that. Y plus 2 equals square root of x squared. X equals y plus 2 squared. See? So then we would have gone integral. And then what's this lower limit down here? -2, and the upper limit 0, and then you would have gone y plus 2 squared dy. And then let's see, that should be the same, 2.6667. Now let's see, math, math, 9, -2 to 0, and then we had, what was it, y plus 2? Y plus 2. I'm going to put x plus 2. And then look. Same thing. You see how it's the same? It's just a delta, no calculator. Is it the what? Okay.